Hello, everyone. Welcome to Data Engineering Weekly podcast. Today, we are going to talk about Flush, and we have Jark with us. Thank you so much, Jark, for accepting our invite. How about give a quick intro about what you do and a bit about yourself to the audience?
Hi everyone, my name is Jark and I lead both the Fluss and Flink team at Alibaba Cloud. With a decade of experience with Flink, I have been deeply involved in the development and the evolution of Flink from Flink community from zero to now. Along this journey, I created and incubated Flink CDC project and the Fluss project. We are going to talk about the Fluss today.
One of the articles that caught my eyes on the article that you published on Alibaba Cloud, essentially, it's about top 4 challenges using Kafka for real-time analytics. And that's why I got to know about Flush project. To the audience, can you explain what is Flush and what is the need for a Flush into an architecture?
Yeah, Fluss is streaming storage specially designed for real-time analytics and to address many challenges when we are using Kafka and Flink together to use them in the analytical scenarios, such as when you combine Kafka and Flink, you will find it is not a perfect fit and you will hit a lot of problems. And we can discuss the problems later. And also, when you integrate Kafka and Lakehouse, integration of Kafka and Lakehouse is very narrow, and we also have some problems in this integration. And so you can think those analytical Kafka that would on top of Lakehouse architecture and can integrate seamlessly Flink to reduce the cost and achieve a better performance and to unlock your use case with time analytics. And the name of Fluss comes from a short word called the Flink Unified Streaming Storage. We picked first and combine the Fluss word. Very interesting, the Fluss is also a German word, means so it is a German word and pronounced Fluss.
Okay, it's called Flush. You mentioned one thing very interesting is if an organization already using Kafka and Flink, what is the need for Flush in the middle? Like why an organization should consider Flush? Because I already have Kafkas coming in and I have Flink in my stateful system that I already have in my state storing in. And what is this tool cannot solve a problem that Flush efficiently solving it?
First of all, the purpose of Fluss is not to replace Kafka totally. It just wants to be a better stream storage for the real-time analytics. Especially I'm leading the Flink team at Alibaba, and we have a lot of use cases to use Flink to build applications. We have more than 20,000 Flink jobs in Alibaba, and we also Alibaba Cloud to help many small and medium companies achieve their real-time applications. When we talk with our customers and users, and the pain point when using Kafka with Flink, the first pain point is Kafka is not editable. So it is just mutable log system. You can only append data and count to locate the data. And data mutation is a very basic function in data warehouse or database or real-time database. It is a critical feature that is missing in this system. And the second problem is that Kafka doesn't for example, to store and reprocess data from 7 days ago or months ago. First of all, Kafka is not good at to store a long data because it is usually it only store several days data. But the data warehouse tools usually maybe will store only data. The second, it is hard to reprocess data because all data will go through the broker and hit broker, and there be a big pressure to.
Correct.
And the last problem is the networking. And networking cost is the majority cost of Kafka in. And when we consume the Kafka data to build our real-time applications, not all of the columns are needed. In Alibaba, almost in the 20,000, more than 20,000 Flink SQL jobs, 50% columns will be read for the Flink SQL job. So, but you have to read 100% columns and deserize all the columns in the Flink side. So it is a big cost of networking and cost. So we need to use the Fluss to resolve these problems and to better integrate with the Lakehouse architecture.
Okay, that's very interesting. One thing that Kafka guarantee is that when you are writing a streaming data into Kafka, you can have multiple consumers consuming from different point in almost like near real time, right? You mentioned about Flush, where you are trying to mutate. Does this Flush support real time continuous execution of data, like consumption of data, if you are running a SQL on top of Flush?
Yeah, Fluss can be used like Kafka to streaming read and streaming write. So you can have a producer to continuously publish your log data into the Fluss system and have multiple consumers to consume the log with different log set point concurrent, and the performance is no different from Kafka.
Okay.
We also have the mutation for the table. We have two concepts in the Fluss one, so two table types in Fluss. One is the log table, and another is primary key table. So log table is just to support appending operations, just like a Kafka topic to append log data. The primary key table have a primary key definition on the table, so it has the primary key constraint to guarantee to only one row for the same key. So Fluss will guarantee that to update or replace data if you write the data with the same primary key.
That's very interesting. So I'm just trying to compare with Kafka because some of the pain points that you mentioned about Kafka, one of the things that Kafka is going to do that is maintaining the consumer offset so that at a different point in time, a consumer is consuming and consumers can resume from a different point in time based on the consumer offset, essentially. Flink is trying to do by maintaining the checkpoint on its own. Does Flush support out of the box offset management system for the consumers, or is it fall under specialized consumers like Flink has to maintain that?
Currently, Fluss doesn't maintain consumer offset. It relies on the external system like Flink to maintain their own offset in checkpoints or somewhere. But in the future, Kafka Fluss is targeted to be Kafka compatible system to be compatible with Kafka protocol. So the consumer group is featured on the Fluss roadmap, and we also see the strong requirement on the consumer group because it doesn't need to store consumer offset. So you can very easily restart or start a new Flink job in a new cluster, interesting and good feature to add in the Fluss system.
The other question I had is you mentioned about primary key table. If I understand the difference between the log table and primary key table for the audience, Flush has two types of tables, primary key table and the log table. Log table is immutable in nature, similar to Kafka. Primary key table has a primary key. So if you're writing to the same key, it get updated, like updated the rows. From a consumer perspective, let's say I have a primary key table and I'm consuming the primary key table here and a row get updated. Will it behave like a change data capture where if you're updating a database, for example, MySQL, the CDC essentially gives you what is the previous version and the current version for me? How does Flush essentially work here?
Yeah, exactly. You have catched the point. Yeah. As the design of front key and consuming mechanism is just like change data capture in database systems. When I upsert or I delete a request on the primary key table, we will look up the previous row and combine with the current row and write the change data into our log system.
Okay.
And the log system will be responsible as a write-ahead log for the primary key table recovery. On the other hand, the log will also be consumed by Flink in a streaming way.
Okay, if I understand correctly, so the primary key table get updated, the change data capture written as a log table, so you get both the things streamed and joined.
Yeah.
You can consume.
So it isn't just like combined with a log table and Redis. So Redis, we store or majority the real of our table. The log table stores change data captures, and carry and the carry and the log, they are just like a string and table duality. So yeah, you can recover from the log. You can recover the table carry from the log, and it captures changes from the carry table.
So currently, if I don't use Flush, I should use some kind of a key value external storage like Redis or Aerospike, where I should maintain my primary key table, and the stream data comes from somewhere else. I have to capture the change data capture from Redis, and then so Flush kind of avoid maintaining multiple such databases. Is that a right statement to make?
Yes, exactly. Flink is a streaming processing system, real-time streaming processing system. Yeah. So that is very critical because we always will have up-to-date data in your systems, like a database or somewhere. And so the change data, so the one of the main power of Flink SQL is it can process the change data capture, the CDC data, the change data. But not many systems can produce complete change data like MySQL CDC, but Kafka doesn't provide that, and some KV system doesn't provide it. So Flink has to maturize the change data and to produce a complete change data by itself. So it is a big cost in Flink SQL to guarantee the result correctly. So we have the primary key table design to resolve this problem. So you don't need to dump your Kafka log into another KV table. You just use Fluss and data to Flink to consume your data.
Okay, that's very interesting. So you're like, yeah, state management is one of the hardest problem in Flink. Personally, I advise people not to adopt Flink because of the state management problem. So you are efficient moving away the state management and became the stream framework much more lightweight to adopt more real-time streaming application for you in this case. One thing that you mentioned is very interesting that one of the problem for Kafka is it consumes all the messages. There is no way for me to select only the particular columns and store the data in Parquet format, if I understand correctly. Is that so why the design choice of storing a columnar format? Why the columnar storage format there?
Our start point is we want to make the stream storage more friendly or more efficient for the real-time analytics. And analytics workload very common to only query part of the columns or filter to almost most of the data. Storage, the analytical storage usually have the your ability to support data skipping. So they almost using the columnar storage and with the footer, with the statistic, max min, group filter index to have your ability to filter data. This is our motivation to bring some analytical concepts designs into our stream storage. So we start to looking for what is the good format for our streaming storage. We design some role-based format, but that doesn't work perfectly. We start looking into Parquet and Arrow, Apache Arrow. Parquet storage is a Parquet format for storage, and Arrow is the column storage for data exchange and in-memory processing. In the end, we choose Apache Arrow as our format because Arrow provide a feature called streaming format, the IPT streaming format. So you can write your Arrow batches and streaming read error batches. But Kafka doesn't support a streaming format. If you want to publish Kafka data, you have to write a folder. But our motivation is a millisecond real-time distance.
Yeah.
You can't to write Kafka data in such frequency. It will be a lot of small files. So we choose the arrow batch. We can append many arrow batches into one big log file, and once the file reaches 1 GB or 2 GB, we can close the file and start a new. We can resolve this problem. And it's done.
Okay, yeah, I think that was actually my follow-up question, because when you are writing into a columnar storage, you have to buffer it before writing. You also mentioned the write throughput is equal to Kafka. That's why you mentioned about like Apache Arrow, which is streaming batch, is an underlying architecture that you work in. Right? You mentioned about you started with a streaming, like row-based approach, and then the Parquet-based approach. Do you know what is the performance gain that you got with Arrow streaming batch?
The main performance gain is the network cost, reduce the network cost and the reading throughput, because the Apache Arrow store data in columns. We can read the data, just read the column, just read the data that your current data you needed. You don't need to transfer unneeded current data. So it has a big reduce of the networking cost. We have for the current pruning. If you read on 10% of your currents, and you will gain almost 10 times performance improvement in the read throughput.
Okay.
So it is a very big improvement.
Yeah. So before jumping onto Fluss internal architecture, I'm curious, if you see the OLAP engines like Apache Pinot or Starrocks or Lakehouse, for example, they are also trying to do a similar use case where you don't need to query the streaming data, but query the storage, which is much more performant. So how do you compare your system with the OLAP engines like Pinot and Starrocks? Or do you feel Fluss is the beginning of the hybrid between Kafka and OLAP? There is a middle ground between those two systems.
Focus on streaming storage, it doesn't provide data processing. So it has to work with the computation engine or query engine like Flink, Spring to do streaming processing, or use Spark to do some batch query processing. And Pinot and Starrocks is an OLAP database that supports low latency analytical queries. So it has a very strong ability on complex queries. On the other hand, it also stores data by its own. So it is a combination of computation and storage. It has its data and computation. If you look at the Pinot architecture, so Pinot has additional query service, maybe called broker, correctly. And Jark has the front end to dispatch subqueries to the back end to process. But Fluss is just a storage system, just like architecture is more similar.
Okay.
Design principle behind is design principle of Fluss behind the scenes is that we believe the future is composable architecture. And the rise of Lakehouse and Iceberg, I think it has already proved its power on composable architecture. So user that can pick OORC as the file format and Iceberg or Data Lake as the table format, and use Flink or Starrock or Spark as the query engine to support different query scenarios or lab stream batch, and be one component or one layer in this architecture to bring the real-time data. So it focuses on doing good in the storage.
This is more of an unbundling of OLAP. And considering you mentioned composable databases, Apache Data Fusion is another project that is actually providing you decomposable way of running SQL engines. So you can plug into any data storage components like Fluss, and you can efficiently build more and more interesting component on top of it. So yeah, that's really great things to do that. Now, just get some understanding of how Flush work internally. We have this data comes in, and how does the data, like how does a producer identify where to write? Typically, audience might have been well familiar with how Kafka works, for example. You write into a broker, and then broker coordinate themselves, and then there is some rack consensus. Used to be a zookeeper, now Kafka has its own care of implementation of the things, right? How does Flush work internally in that case?
A similar architecture like Kafka, we have a coordinator server and table server. So two components. The coordinator server is like the Kafka controller, but our coordinator server is individual process, individual component.
Okay.
It is not a bottleneck. The table server is just like a broker to store the data and responsible for serving the reading and the writing requests. And the coordinator server is responsible for cloud management and the controller and maintaining the metadata, creating a table and assigning.
Okay.
And
yeah, what about the tablet server you mentioned?
The table server is responsible to store the data and when, for example, when a table is created, and the coordinator will create the metadata and assign replicas to the table.
Okay.
We are using the same replication mechanism like Kafka.
Okay.
So synchronize. For example, by default, it will have 3 replicas, and the coordinator will choose the 3 replicas, and one of them is the leader, and notify the table server to set up the. And when one server receives this request, and it will create log files in the local distro, will start to fetch the replications from the leader. Mm-hmm. Once the leader is filled, so the coordinator will pick a new leader to take over the responsibility. And the switch, the failover time may be in second.
This is a very common architecture in many of the distributed systems when I have a coordinator service.
Yes.
And I wish somebody kind of unbundle the coordinator service alone. So easy to build those other distributed component system around that. You mentioned about Apache Arrow usage is a streaming batching. So if you are using streaming batch in Arrow, how does the replication work? Is that flush that into a typical wall format, or do you write an Arrow format for replicate across different servers? How that works?
It has nothing to do with the replication, because the Arrow batching is batched in the client side. Because most of the workload is written by some Flink connector, so Flink sync can be responsible to batching the data and writing into Arrow batch, send the Arrow batch to the server. The server just think it is okay. It is the Arrow batch. Okay, I will just put it into our local data or page tag.
Oh, okay. Okay.
So replication of binary data to local.
Yeah. Okay. So one of the question around scalability in the primary key table, one of the challenge companies face is even true for Kafka, for example. If I partition by user ID and I send all the data for like maybe 64 partition and I maintain certain orders associated with that one. Now I have my data coming a lot. I wanted to repartition myself. Then I miss the order because the hashing changes. User ID might end up in a different partition completely. And there is a window of period I will lose the order essentially. So how flexible Flush in terms of our scalability, like auto scaling and other aspect of it?
Oh, you mean the skills additions and auto guarantee out of order first repartition. Yeah, that is a very good question. And currently we didn't support, we doesn't provide a partition rescaling feature in Fluss, but we have internal design to how to do this in the future. And this is on our roadmap. The first of all is how to replicate how to rescale our private key buckets into new set of buckets. we learn from the Flink rescale mechanism, and Flink uses a key group mechanism to do this. First of all, Flink has the state backend and stores the state in different tasks, and it also has hash calculation to hash the data into individual tasks, and it will define a max algorithm. So it is the upper limit when you want to scale up, and when you have the max algorithm, it will first hashes the data and divide by the max algorithm. So you will have the first level key group ID, and we will assign the key group ID into different tasks. So what each task has different range. For 1 to 10, it is responded by task 1.
Okay.
And when we want to rescale the data, and when we want to rescale the data, the task will, the key group range will be assigned to different tasks, and the tasks will fetch the data belong to it.
So it is essentially you're doing a ring hashing, and a new hash allocated, new ring, a node been added to the ring. The consumer also know the distribution changed, and then it will try to consume from the different ring so that the order will preserve. Is that my understanding correct?
Do you mean the ring hashing?
So you mentioned different range allocated and new node added. Is it more like a ring buffer hashing model?
Yes, they are similar like that.
One of the question I had, it seems like Flush, by name it is Flink, but it is very tightly coupled with Flink. And Flink is already like a very heavyweight system to run on its own. Maybe because there is a lot of state management, so state management needs to be handled. And if you introduce Flush, that makes Flink lightweight. Now, do we need Flink such a heavyweight component? Do you envision a lightweight streaming framework on top of Flush to do this job?
Flink is creative to manage the state, especially when the state grows larger and larger. We have many users complain about this, especially when you're doing streaming joins, will persist all the data from the two streams into the state. So if the state is very, 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 it introduces a lot of problems when you want to rescale the job, and it will download all the data from the S3, and it costs a lot of time. And once we introduce rules with Flink, we can offload some state into the rules. You can think rules as external state of the Flink. Flink first can store a large amount of data. It is a scalability with the temporary server. Rules and Flink can be computation and storage separation architecture overall the data into rules to make the computation and storage to scale up individually.
Oh,
and this also makes the job to rescale or restart very easy.
do you foresee an interoperability with systems like Kafka Stream and other type of streaming framework in this case?
Do you mean to integrate rules with other streaming framework?
Yes.
Yeah, it is on our roadmap, and we have a pull request that supports Spark Streaming later. You can use Spark Streaming to process the rules data in streaming mode or batch mode. Yeah.
Okay. So one of the interesting thing you mentioned about like Flush store the data in a columnar format, but it not necessarily gives you computation. Now Flink has to fetch. How does Flush handle push down predicate? Does it support, and what are the capabilities that Flush have? Is it only restricted to only for a selected projection of columns, or do you support push down predicate also into this?
Currently, we support. So when when the user writing a SQL query and select what colors, and the planner will analyze the query to tell the connector to tell the rules which columns is selected. So only these selected columns will be transferred, right, to reduce the cost of networking and reduce the connector to destroy the rows. And the filter push down is also on our roadmap. The rough idea of this filter push down is using arrow statistics, but arrow doesn't support batch, and arrow doesn't support statistics right now, but it has working process proposal of the statistics. It defines down protocol how statistics arranged, and we are going to use these statistics like max min on each column to filter our data. For example, if users write a condition like 50 equals blah blah blah, 50 equals San Francisco, and we have the max min on the 50 column, and we will compare the condition with the max min with values to quickly filter out batch, the error batches. And idea, and we have an issue to check that.
Yeah, I think that may be the bigger killing feature in my opinion, because from my perspective, one of the bigger problem with Kafka is the head of the line blocking. This is true in many B2B systems where B2B is processing all the individual customers, and not all the customers are same. Like some customers send like huge volume of data. So a lot of other customers send a very small amount of data, and you wanted to give a high amount of processing power to the large amount of data processing. But currently in Kafka, you cannot do that because there is no push down predicate.
That is the big problem of Kafka, because Kafka only supports sequence read, and that is a big problem in details.
I'm very glad Flush is already working on that. I wanted to a little more understand about the fault tolerance nature of it. Let's say a node goes down. What will happen if a coordinator server goes down? How does Flush handle the fault tolerance? And also tablet server goes down. How does internally this handled?
Currently, we deploy our clusters on Kubernetes. Once coordinator server is down, the Kubernetes will automatically restart support. Maybe in this, maybe on this same node, maybe on another node, but it will restart a coordinator server. The coordinator server is a database, so it doesn't matter which node to start the server. Our metadata are stored in zookeeper. So coordinator server is a database.
Okay.
If a temporary server is down, we have a similar replication mechanism with Kafka. If one of the broker, it would be one of the temporary server is down, the coordinator will to choose the new leader of their partitions to assign them to the new brokers. And once the field server recovering, it will catch up using logs for the new leader.
Speaking of replication, right? Like most of the enterprise need is having this geo or cross data center replication. Do you Flush does aware of the data center replication model right now, or is it in the future roadmap?
It is our feature roadmap.
Yeah.
Lot of exciting features in the future.
If anybody is interested in Flush or contribute to Flush, how should we reach you? And I know what is the best way for them to try it out and get familiar with the system and also contribute? What would your advice?
I think if someone is interested in Fluss, it's very welcome to join the community, and you can contact me on LinkedIn messages. And you also, it's very welcome if you want to start to contribute to the system or to know the underlying of the system. It is the official documentation is the good start point. We have the blogs of introducing Fluss and why Fluss, and documentation to introduce the concepts, the architecture, and how to use the filter and quick starts. So first step is the documentation, and you can go through you can download the code to read and try out the system. Also, you can go into the GitHub issues to pick up good first issues as a start point.
And are there any existing customers or companies that are using Flush in production? Can you name anyone if possible?
Yeah, currently Fluss is mainly used in Alibaba internally, and we have some good relationship with other companies there, and they are in POC of the foods like ByteDance and Tencent, and I'm in China, and in production in our system, and so yes, most of the jobs is migrate from Kafka-like system to Fluss, and the motivation of the migration is especially from the current format, and seamless integration with Link to reduce the total cost of like it can reduce the Flink data cost and reduce the networking cost.
Oh, okay. That's great to know. Thank you so much, Jark, for sharing all the insights about Flush. Flush, especially very interesting to me because it does really solve some of the very key problem that I'm also facing right now to solve this head of the line blocking and the how do we do the real time analytics much efficient way. So will definitely look out for this project, how it grow. Thank you so much for sharing all your insight. Yeah.
So thank you for the chance to for me, and I'm glad if we have the future chance to meet in person.
Yeah, definitely. I'll
And
do that. Great. Thank you so
yeah,
much.
thank you.